Hi guys, so I'm Han. I am a long time Mac developer, but last 18, 24 months have actually made a switch over to data science. And so one of the most surprising things was what we got from WWDC this year, which was a really, really powerful core ML framework, which is very good for machine learning. And I'll give you a reason why that's really awesome. But I thought that this would be a really good opportunity to talk about machine learning, coming from somebody who's also done Mac programming and bridging the chasm that's actually between data science and applied data science. So the way I see it right now is that there is the research data science, the guys who attend the Melbourne Data Science, AI, ML meetup, who are very interested in writing archive papers but don't really care about actually seeing their algorithms work in the real world, and app developers who have really great ideas, talk to customers and say, I have an idea for X, but I don't have a model to do Y. So this is hopefully a brief introduction to the world of machine learning for app developers. So firstly, nomenclature. Like, you'll see a lot of different terms thrown around, and I was just going to hopefully give you a brief rundown of what they all are. So if you watch the Apple keynote, not once, maybe once actually, Craig mentions the word deep learning. You watch Google I/O, Sundar talks about deep learning every 3 to 5 minutes, right? So this is really a brief introduction. Machine learning. So what is machine learning? Machine learning is a way of teaching machines to code themselves based on lots of data, pattern recognition, images, sounds, text, right? Under that, you have a whole bunch of different methodologies. You have your simple linear regression, which is really a machine learning algorithm. Scalable vector machines, hidden Markov models, random forest distributions. My favorite of the moment, and kind of like everyone else as well, are neural networks. And the reason for that is that we've seen some really amazing models and results come out from that. Under neural networks, you have a whole bunch of different terms. Deep learning, well, really, to be honest, what deep learning is a neural network that has more than 3 layers stacked on each other. That's really what deep learning is. But under deep learning, you also have lots of different types. You have multi-layered perceptrons, which are essentially neural networks, very simple artificial neural networks that are just stacked 1 by 2 by 3. Then you have convolutional neural networks. These are really the star players at the moment and have actually resulted in the best performance in our image recognition task. ImageNet, all these programs that you see, the Apple demos with Core ML, built on convolutional neural networks. Hot dog or not, also built on convolutional neural network. Then you go down to recurrent neural networks. Recurrent neural networks are very popular. They're starting to show promise at the moment. They're specifically very good for time series because you have memory. So if you have, say, stock predictions and you want to predict what the price of X is, you use a recurrent neural network. If you want to do speech analysis, recurrent neural networks, accelerometer data, all that, recurrent neural networks. Then you go into some really weird space. So the ones that I talked about are what's called supervised machine learning algorithms. So you give an example of X and you say, go learn the pattern to predict X. The other two, generative adversarial networks and deep reinforcement learning, are in the very cutting edge space of unsupervised machine learning. So generative adversarial networks are really interesting because what it is they're 2 neural networks. And if you imagine one neural network being a cop and the other one being a forger, it's the job of the forger to make copies of something and say, hey, cop, can you tell whether it's fake or not? You do this lots of times. Eventually, the forger gets so good that it actually tricks the cop that you can start producing images, music from scratch. So you can say, hey, Gan, I want you to produce an image of a blue bird on a blue background and a green hill, and it will generate an image completely from scratch that is photorealistic. That's the current state of the art. And then you have deep reinforcement learning, which is really cool but also a bit scary, where machines are learning to do tasks based on observing people and being rewarded for a particular task. The best example is Mario. Deep Brain trained a neural network to play Mario just by observing human players play and to know what works and what doesn't. So those graphs here, the top one is really a very simple illustration of a neural network where it takes several inputs, x1, x2, x3, puts them through a dot product, and you end up with a prediction on the y side. Usually you also have an activation function in the middle section to actually say whether that neuron would fire or not. The second one is what happens when you actually chain a whole bunch of these neurons together. So that's a multi-layer perceptron where you feed them together. And then third, the last one is a convolutional neural network where you have X1, X2, X3, X4 forming a cluster that looks at a particular window and it slides across that window with activation functions. And by pairing and having lots of layers of these convolutional neural networks, you end up with ways of teaching the machine to do things that we would usually code into computer vision algorithms, such as edge detection, contrast, color. So the machine is all learning this on its own. So very quickly, applications of ML. There are lots of different types of application: computer vision, speech recognition, NLP, autonomous vehicles, artistic style transfer, really interesting stuff. So you can actually train a neural network to imitate Monet, take a photo, and then you get that. I think there's an app called Prisma or something like that. Does the same thing. Art music generation. So the guys at Google have come up with a project called Magenta. And I don't know, you might have played around with it, where there was I think a web app where you could draw a sketch of a cat, and the neural network would predict that you were drawing a cat. And they've seen, I think, since I/O actually release the source code and the entire data set, so you can actually train a neural network to, if you drew something, learn what you were drawing.
It's like quick draw.
Kind of like quick draw, exactly. Music generation, so that, yep.
What if you draw one of those optical illusions which looks like either a rabbit or a duck?
So my answer would be, depends on how many times you tell it it's a duck. Right. If you tell it it's really a duck, it'll learn it's a duck. But if you tell it that could also be a rabbit, then it'll be like, well, 60% could be a duck or a rabbit. It's really what you teach it to be. Art, music generation, music as well. So Magenta also did that with style transfer of music. So they trained a neural network to do representations of, say, a cow and a representation of a piano. And because you end up with a vector representation of a cow and a vector representation of a piano, you can then combine those two and come up with a cow-piano of sorts. Artificial intelligence, that's what everyone talks about. It's a bit wishy-washy what exactly it is, but I guess AlphaGo beating the best Go human is kind of moving in that direction. And miscellaneous, there are lots of different applications to it. So what is the machine learning workflow? How do we actually use this, right? Very simply, these are all the steps you really need to do. A, get the data, clean it. Most of the time, we do that all the time. All we do is we clean the data, we make it nice. We then choose a model architecture. I was talking about before, convolutional neural nets, LSTMs. You can pair them together and you end up with a model architecture. Then you train your model, right? So what do you do when you train your model? You say, pick a hyperparameter. I want x to be 5. I want x1 to be 5, x2 to be 3, x3 to be 4. And then you set those hyperparameters, and then you test your model by running it all the way through. You evaluate your results, see how good you went, and then you change the numbers again. And what you do is you keep repeating this process over and over again until you end up with a really good set of hyperparameters. And then you deploy a model, and then you profit. So very quickly, this is something that I noticed as well at the labs at the Core ML. A lot of people are asking, so I have a problem such as X, I want to recognize this, I need a model, well, how do I do this? So very quick overview of some of the models I like. Inception v3, VGG16, AlexNet, these are all convolutional neural nets, or stacks of them. Inception v3 being the most famous of them because it won ImageNet in 2016. And as you can see, so Linnet, which was, I think, the first one that came out before 2006, very small architecture. It's only got maybe about 12 layers or so. And then you end up with Inception v3, or Inception BM, which is even bigger, with 133 layers, right? So that's very good for image recognition. Currently is the standard the standard at the moment. Then you have deep speech. Deep speech is a architecture built and developed by Baidu, and it does speech recognition end to end. So it takes raw waveforms and it will output text. So you feed it and say, me saying, I like machine learning, and it will spit out the text exactly for that. You have word to vec. Word to vec is very common. It's a word embedding to actually vectorized language. So you end up with a vector representation of English as a corpus. SketchRNN, which is the one where I was talking about, where you draw a particular image and it'll tell you what it is. And WaveNet. WaveNet is fascinating. So WaveNet is interesting because it's a dilated convolutional neural network, and it can generate very realistic human voices from scratch. They've also used it for generating very realistic musical instruments and music from scratch as well. And also you can do it inversely for speech recognition the other way too. How do you do this? Well, there are lots of different frameworks to train your machine learning model. The big one everyone knows about is TensorFlow, because Google spends a shit ton of money on advertising for that one, which is an ancestor of Theano. What's really interesting, and for everyone here in Apple land, is Keras. So CoreML supports Keras 1.2.2. It's a bit older, but it's okay, it still works. The current state of the art is Keras 2.0, and it's natively supported in TensorFlow. A few of the other ones, Torch, now there's also PyTorch for Python, is supported by Facebook along with Cafe2, a Facebook product. Microsoft has their CNTK, which is their cognitive toolkit. It's really good for time series LSTM data sets. And then MXNet, which is kind of more the open source framework, is supported by Amazon for their deep learning stuff. So let's go across and I'll explain how a model really works. So let's say you have an image of a cat, or you have some text, or you have some waveform. The core of any machine learning model is its inputs and its outputs. And all machine learning does, or in deep learning for this matter, is you need to come up with a vector representation of X. In the sense of images, it's really simple. It's usually a tensor, a X by Y by, if you have an RGB value, so X by Y by 3 tensor. In, say, for instance, text NLP, what you do is you end up with a word embedding that you train on a large corpus. So a lot of the times people use GloVe or Word2Vec. They train it on Wikipedia, and then they have a vector representation of each word that then they can stack together to create a vector representation of a sentence. And then you have audio. So speech is an area that we at Clinic Cloud work very heavily on, where what we do is we... so what happens is that you end up with a train of thought. So you have a time domain representation here. You slice them up into windows. You run a fast Fourier transform, and you extract features called MFCC, Mel frequency capture coefficients, which ends up with a vector. You take your vector, you put it into your model, and all your model is doing is crunching numbers. It's trying to find the patterns, and then out comes your vector, right? And your vector usually is a representation of, was it a cat, the image that you saw? Was it a dog? Was it not a hot dog? Was it a hot dog? You can also then get speech to text or sound to text. So you end up with, a waveform that you said, OK, Google, and it'll come up with OK, Google. Or you can end up with, NLP, where you put in raw text and you end up with an intent, say, set alarm for time 700. So you take unstructured text and turn it into structured. So CoreML. Why CoreML is, so CoreML is a framework that was announced at WWDC 17 and got me really excited. What it is, Vlad mentioned, it's an inference engine, so it doesn't support training. Although having said that, all the recipes are there. So technically Apple has set the frameworks in the ground for potentially training models. They didn't say anything about that. I tried to get it out of that, but I think it's coming in Mac version, whatever the next one is from High Sierra. It's a heterogeneous compute architecture. What's really cool about that is it chooses either the CPU or the GPU. And a lot of people may have heard about the whole hype around GPUs, and yet the hype is real. GPUs like NVIDIA will train models at 50 times faster, maybe even sometimes now 100 times faster than CPUs can. And Apple, apart from NVIDIA, are the only vendors at the moment who have leveraged GPU compute on mobile. They've also they've also shipped a tool called CoreML tool that converts model files from popular frameworks such as Keras, Caffe, scikit-learn into a CoreML model file. And the most important thing is it runs Inception v3 at 60 frames per second. Now, I cannot stress how important that is because the current state of the art with TensorFlow on Android runs it at 15 frames per second because that doesn't leverage the GPU. What's really fascinating about it running at 60 frames is now you're able to mount it on a drone and have the drone fly around and know that it's not going to bump into a tree or something else because it's processing that fast. So this is the reason why it's really awesome and it's a game changer. And if anyone's doing machine learning, you should figure out how to actually get it to run on Core ML. One of the things that I decided to do in my spare time between DubDub and now was to see how we could actually train a model from scratch. So this is MNIST. MNIST is essentially the hello world of machine learning or deep learning. 60,000 images that are tests and 10,000, sorry, training and 10,000 test images. They are 28 by 28 black and grayscale images, so 0 to 255 of hand-drawn digits. And I wrote a simple, well, I didn't write it. I just copied the standard architecture, which is a 3-layer convolutional neural network, as you see here, where it takes an input vector of 1 by 28 by 28, and it outputs a vector of 1 by 10, which is a softmax function to give you the probability distribution that that particular digit that you did was 0 to 10. I don't know why I said it's 1 to 10. 0 to 10. 0 to 9, my bad. So demo. So this is on GitHub, but I'll show you how it all works. So if only my mouse would work. Okay, so Firefox. I have published a Docker image that contains Keras 1.2 and also the tools that you require. Inside that, you will find Jupyter. Jupyter is the Xcode for Python and machine learning people. So inside here, you'll see Keras 1.2.2. This is essentially the source code. All you need to train an algorithm to recognize handwritten digits from 0 to 9. If you so wish to, you could also get a whole data set of A to Z or whatever other images that you really want to, and also put it into this model and train it. So by training that, you end up with this. This is a progress of how well you're doing. So the most important thing to notice here are the two values, the accuracy and the loss. You should pay attention more about loss. So loss, the lower the loss, the better your algorithm is. So train this algorithm, you end up with a test accuracy of 0.99 and a loss value of 0.047. What you then do is you take Keras. So Keras is a framework that runs on top of TensorFlow, and you save the particular file. Then you run this. It's a script that I wrote. What it does is it imports Core ML tools. You tell it to convert the Keras file into a Core ML file. And what you end up here is an input where it expects an array, a multi-array of 1 by 28 by 28 of float or double values, and it outputs a array of 0 to 9, yes, of 10 values. I wonder if I can actually pull out my Xcode here and show MNIST draw. So inside the project, this is what it really is. And what I wanted to get across is if you guys work with data scientists or machine learning people, they most likely work in Python, and they will throw you models across. And Core ML tools can be quite smart sometimes, but I would turn off the smartness sometimes because it's a bit weird. Rather than getting a CV pixel buffer, which is what they usually give you, you say, I want an image, to just get a raw input of an array type, ML multi-array, which essentially equates to a NumPy array. And if you go in here, I'll just walk through the code. Oh shit, maybe I'll move this here and then I can scroll. Okay, so in here we have sorry, this is Objective-C, but I was dealing with pointers, so I didn't really want to do it in Swift. In here we see there's an input array. This is a ML multi-array type, and I'm instantiating it with a shape. A shape is essentially saying this is my tensor that I want it to be in, which is 1 by 28 by 28, because it's 28x, 28y, one value of 0 to 255 for my pixel intensities. I set up my model because I launch it from MNIST Keras, and then and error handling. Predict button. So I'm saying what I need to do is to populate input tensor, and then that's the output. So the output is the ML multi-array that I get back once I do a prediction using that model. And then right here, what I'm doing is I'm just trying to find the maximum probability, the index of the maximum probability, because it goes from 0 to 9. If I find an index of that, I know exactly what I wrote. Populate input tensor. So this is where you take an image, you then go through, iterate the whole thing through, and you populate that tensor. You say, I want you to find the intensities from 0 to 255, normalize it maybe, and then put it into the tensor for 1 by 28 by 28. So you can say, if I want it to be in 0.2 and 2, I'd say insert it at 0.2 by 2. So once that's all done, you just run your model. So let's see what it looks like. So let's run it on a simulator like this one. There we go. And so this is an example of how you would then use a custom model. So if you wanted to, as I said, you could train it on a whole bunch of new inputs. Oh, nice, on this side of the screen. So just example, if I were to write, whoa, what's going on here? Whoa. Hello. Okay. I can pull out my iPhone. Anyone here have a lightning cable that I can? Yep. Yeah, USB. I'm not sure what. Yep. I'll just QuickTime video this demoing. I don't know why it's. Oh, that works. Thank you. Yep. Yep. Well, it's not wireless debugging. It's more I want to show you guys how it would all work. QuickTime. New screen recording. And whoa, why does it not show up my iPhone? Oh, is it new movie recording? That's the one. I'm not in iTunes. Where's my QuickTime? New movie recording. Oh no, it's on the other side of my screen. Oh, there we go. Excellent. Oh wait, can you see it? There we go. So MNIST draw. If I were to draw, say, number 4, predict value is 4. Nope, no minus figures, but let's see. 7 or 6. Oh, ooh. 6, and then 3, and so on and so forth, right? So this is it. So you train it on MNIST and you deploy in CoreML. Yeah, questions?
Is it a constant time, once you train the model, is it constant time to do the prediction?
Yep.
Yes.
Yeah, once you've trained a model. So what happens is that as you're training a model, the way I would describe it is that in functional programming, in a sense, you end up with a computational graph. As part of the computational graph, you need to know what the numbers are for your coefficients. Once you've saved your model and you've ported it to CoreML, what you're doing is you save those numbers, and as you're doing it through, it just computes it linearly all the way across.
So what affects the amount of time, processing time it takes to do a prediction? Is it the size of the model or the data set, or what
Both. So inception is very compute intensive because there's 133 convolutional layers. So it has to convolve each pixel by, say, a stride. So there are two things. So it's the size of the model and the size of the image. Now, what's really important to realize as well is, and Apple never talks about this, it's so easy, right? CoreML, just drag and drop, is that inception only recognizes fields in a square area. So if you look at CoreML, if I can pull this up here, it'll say Dropbox, go away. I can't even get to Dropbox. Anyway, here we go. So I can't. My mouse doesn't go past that invisible thing. I don't know why. It's like an invisible barrier. But so you see, there's a ML multi-array 128 by 28. If you look at the Inception v3 model to give you, it's 1 by 217 by 217. So a lot of people have been going, oh, it's not recognizing X. Well, that's the reason, because it's only taking 217 pixels in the center of your frame. And a lot of people are taking like portrait or landscape images, and whatever image that they're trying to recognize is outside of the area. So yes, image size, because it has to convolve each time over the image size, and the architecture of the model as well matters. Now, having said that, I got really excited when they said when I saw it 60 frames per second, because nobody else out there except for NVIDIA has been able to pull off 60 frames per second Inception on a mobile device. So anyone out there with really cool ideas, go make it on CoreML. Any other question I saw? Yep.
How did you? There is another GitHub project. I've seen it cropping up all the time with like million stars and stuff.
Yep.
It's in Swift and it's called machine learning or something.
Uh-huh.
AI. I don't know. You probably come across it. It's got like I never understood it, but it's got like 5 sample projects. One of which is number recognition.
Yep.
And there's some testing process to kind of understand your handwriting.
Yep.
How did you do that? How did you get it to work out your handwriting and calibrate itself to recognize handwriting?
So the thing about it is that you don't, the whole beauty of machine learning, or at least with deep learning, is you don't calibrate. The machine is supposed to learn the core principles of what you as a human see in the image and generalize that, right? If you have to calibrate, you've kind of failed in deep learning or machine learning, right? So what this does with the 3-layer convolutional neural network is it's looking at, all right, where is that stroke for the 3 going through? Where is the edge? A 3 is going to look different from a 7. So it learns these patterns and tries to apply it. So whenever you throw, if somebody else comes up and tries to write a 3 differently from mine, it should try to recognize the 3, because all 3s have very similar properties, right? You have a line in the middle and 2 on the top and some curves on the side. So I don't know about that particular project. They might be using a recurrent neural network where they're tracing every single stroke, which maybe might be more accurate. But this one is a pure image-based stuff. All I'm doing is when I draw that image and I hit predict, it's saving a bitmap of that particular black box and running a convolutional neural network on that. But yeah, that's pretty much it. Any other questions?
So if you draw a squiggle on that, it's going to give you a prediction of a number between 0 and 9.
0 and 9, exactly. Except
Except
the probabilities may not be necessarily 1. It might be like 0.5, 0.6, and it's just finding the maximum.
No.
It won't say it's a cat. So this is the most important takeaway as well. If you're going to be using Inception v3, please note that there's only 1,000 categories it's been trained on in ImagineNet. So if your category that you're trying to recognize, like Skittles or I don't know, cupcakes, isn't in ImageNet, it's not going to find it. It's going to say something really weird about it. Like, I don't know if you look at the Twitter stream for CoreML, people are going, hey, this thing is so stupid. It thinks my MacBook Pro is a space heater. Duh, it wasn't trained on a MacBook Pro. So it tries to approximate what it thinks is closest to that MacBook Pro, which I guess a space heater kind of looks like a MacBook Pro anyway. So what you have to do is, let me just go back to my PowerPoint. I don't know if you can see this, but oh God. All right, Dropbox, go away. So if you see that in Inception, there's that purple layer there, that's called the Softmax function, right? And if you, before that area in the yellow line, the yellow box, it's what we call the bottleneck, right? The bottleneck is the most interesting part. So there's a really interesting property of deep neural networks called transfer learning, where a neural network has learned to approximate, edge detection and all the things that the visual cortex kind of does. If you slice off the layer just after the orange layer and you retrain it on your set of images, say Maltesers and Skittles and whatever else, it will do really, really well at recognizing Maltesers and Skittles and what else. Essentially, that's what Hot Dog or Not did. The guy sliced off the last 2 layers and said, everything that I'm showing you is a hot dog or not a hot dog. And it was very good at approximating that. So if you're going to be using Inception v3, make sure you do that on your categories that you're trying to recognize. You'll get really good results. It's proven. Yeah. But apart from that, yeah, if you guys have any questions, I'm going to be around for a bit.
See the one about the labradoodles and the fried chicken?
Wait, is it trying to say that the labradoodle is the same as a fried chicken?
I'm not sure what they queried, but basically it came back with all these pictures of labradoodles and fried chicken. It's like, you can't tell the difference.
Probably wasn't
They
trained.
look, except that they have eyes.
Oh, wait, yes, there was one about the chihuahuas versus the cupcakes. And I mean, it makes sense. Like the chihuahua is brown with like 2 black eyes and a nose, and a cupcake sometimes has like brown with a couple of blueberries or whatever. I mean, I would probably get like confused if I didn't know what the context was around it. But I mean, we can only do so much with machine learning. But I mean, the reason why I say it's really cool as well is that, so Inception, to give you perspective, is 133 layers. ImageNet has 1.5 million images, 1,000 categories. It takes Google, I think, about 2 weeks to train on 150 GPUs. Right? So it takes a long time to train this, and it's kind of cool that they give it to us back to the community for free, and let us go muck around with it. Having said that, they don't actually release the complete source for free, so a lot of researchers go, how did you get such good performance? Because we can't replicate that. But that's a discussion for another day. Yep.
Is there a marketplace for models, for generated models?
Yes, there is a marketplace for that. It's unfortunately server-side. It's a website called Algorithmia. And they're based on AWS. They have things like style transfer. Style transfer. So you can take an image and you can say, I want to look like Monet, and it'll take that thing and apply a convnet and generate an image like Monet. I think they have NLP models and a whole bunch of things. So that's mostly server-side. You end up paying them for that stuff as well. The Core ML stuff is really exciting and really interesting. I mean, it's kind of weird as well because as a data scientist, you're going, well, who's going to pay for my models? Like, you might buy my model for 99 cents, and then boom, on the App Store, you make like $1 million, and now I'm poor, right? So that's kind of the weird thing that nobody quite knows how to resolve yet. But sooner or later, we might end up seeing an App Store for models where you can go, I don't really care about poodles or that. I just want to know whether it's a cupcake or a chihuahua. And you just give me a whole bunch of images for cupcake and chihuahuas, and I'll train it for you and go, yep, that model will do exactly as you asked for it. But yeah, Algorithmia is probably the go-to place right now, I think, for easily accessible cloud-based stuff. But I think Apple has declined.
Like buying pre-trained models.
More of a SaaS service. You have an API you call, you throw your data up, and they give you. Yeah.
All these guys like AWS, Linux,
Yeah.
Microsoft, they're all providing, either pre-trained models, which you can call as an API, like image recognition for
Mhm.
object detection and stuff. But there's also, there's a market maybe for some, buying like, I have something that is pre-trained to very fast upload, right?
Yeah. Well, here's a really interesting thing, and something that it sets Apple apart from everyone else. Apple does not have a cloud business, right? They've obviously drawn a line in the sand and said, we believe the future of inference. So training is a completely different thing, but inference is the next thing. Inference for machine learning is going to be on device, on the edge, and by investing heavily into Core ML, making it easy and attracting data scientists. I guess I'm iOS, Mac developer as well, back into this fold. It makes it really interesting now because you don't have to pay for server costs. You don't have to pay, for GPUs, or you don't have to pay for all these cloud stuff. You just deploy it and it runs. So, and it also runs when there's no connectivity to the cloud, which is a really big plus.
Also helps with your business model too. You don't need to think about where the money needs to be generated from to pay for service.
Exactly. Yep.
You still have to pay for all that server infrastructure or whatever to compute your model.
Unless you buy it straight off the
Well, that's why I
App
guess
Store.
is where I'm thinking, where this will become more like, components
Absolutely, and the thing about it is that it's all additive as well, right? So one example that I didn't mention here as well is that people have started to do things with video, right? Convolutional neural nets combined with long short-term memory units, right? Because it's images and over time. And what's really cool is that now you can actually get a neural net to watch a video and it'll annotate exactly what's happening in each scene very accurately because you know what happened in the scene before, what happened in the scene after. So it can go, yes, this lady is unpacking her car rather than packing it because you know they saw it taking out stuff rather than putting it inside. So yeah, you know, having a combination of all these things, you may end up with some very fascinating stuff. And again, more data flows back to the system, the better it gets. Yep.
So, where Apple's pitching just dropping a model that's already been trained in.
Yep.
And some of the models were not lightweight.
Yep.
At the moment, if you wanted to have a newer model or an updated model or a model that had maybe some extra things that you knew about, so like in your case, just knew about numbers 0 to 9,
Mm-hmm.
and you go, oh, I've got the alphabet.
Mm-hmm.
We'd have to ship a new app at this point. Is that right? Like, there's no easy way of going, I'm going to update that dynamically.
Yes, you'd have to ship a new model.
Model's just a file.
It is a file, but it gets compiled down to metal shaders, I believe. So the
build, you can't download it.
yeah, so because the thing about it is that your computational graph may have changed from version 1 to 2, right? So you say, I'm going to add extra convolutional neural network layer into like 135 out of 136. What CoreML does is it looks at the entire graph and it goes conf, fully connected, softmax conf, right, or whatever. And then it generates metal shaders for that, and then it runs it through the metal shaders. So if you update your model, if you update the weights, I don't know if they're going to think about doing that, that's okay. But if you change the architecture, it has to be recompiled down again.
There's no reason why they couldn't do that otherwise. Like, it would be purely a decision until then.
I'm sure they can. I mean, like right now, somebody mentioned on Twitter as well that if you download the IPA file and unzip it and all that stuff, you'll see the model anyway, which is kind of bad, right? Because you don't want to ship a model that somebody else can go copy it and put into your other app. So, there are pros and cons. If you want to protect your model, that's something for Apple to think about, maybe by GM or maybe by iOS 12 to think about. But we're pretty much at day 0. Very excited about this. If you're not doing any for commercial reasons and you just want to muck around, this is perfect stuff.
Cool.
Yeah. No worries.